Hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for this series. Okay, so this is the CompTIA Security Plus certification exam preparation guide. We're in lesson 4. In lesson 1, we looked at like fundamentals of cybersecurity, most cybersecurity concepts like confidentiality, integrity, availability, non-repudiation. We also looked at authenticity, authentication. We looked at IAM, identity and access management, but just an introductory manner. So here we're going to be looking at it as a module, because if you look at the curriculum, in the curriculum, you will see there are some things that you're expected to be able to summarize, right? To summarize, some things you should be able to like explain, some things you should be able to compare, some things you should be able to implement. So those are keywords. And that shows you that tells you the extent to which you should understand the content, because some items are just for you to understand on passing, whereas some items you should have very in-depth knowledge to them. For the students on the study group and the internship, there is an Excel sheet we normally use for exam preparation. So if you're interested in taking the S+ exam, you can reach out to us to get your voucher at 10% discount, or you need mentorship. If you get your certification through us, you get free training, free mentorship, and all of the materials you need to prepare for your exams. And also, you have about 1,700 to 1,000 exam likely questions that mimic the exam curriculum so that you can be better prepared for exam. The goal is to score at least 800 in your exams. Okay, let's look at module 4, where we look at implement identity and access management. So identity and access management is very key in cybersecurity because it helps us to be able to implement authenticity, so that we can authenticate who needs to have access to information. Because this is also a very important step in the 5 elements of information security. So the objectives we're going to be looking at is implement password-based and multi-factor authentication. So here we're looking at not just having a password-based system, you have a username and password. No, we want to go step, not just having password, but having 2, 3, 4, 5 other ways to like authenticate, to like be sure, double sure that somebody is who he says he is or she is. Then we want to go to implement account policies and also authorize some have some authorization solutions. And we'll talk about single sign-on and federation identity solutions. The key thing here is that for single sign-on, you're trying to access, let's say you have Cisco.com. On Cisco.com, you have NetAcad, which is a platform they have. You have the Meraki, you have their Skills for All, you have their device, you have their firewall solution, you have their cloud solutions, same company, same domain name. There might be subdomain names or sections on the website, but just one company. So you could implement a single sign-on system. Or take, for instance, CompTIA.org. So you can have CompTIA.org, CompTIA.com, CompTIA, different domain names within one entity. So you can implement a one sign-on system so that the same username and password you use in signing in that particular section or website of that company, you can use same to do for the other section, so that you don't have to have so many passwords and the rest. But for federated identity solutions, here you're looking at how can we have a third party, something like Google, and your username and password, you could use it to access multiple sites. Take, for instance, you could use your Gmail to access YouTube. You can use your Gmail to access Cisco, to access CompTIA, just one email, different identities, right? So these are the things we're going to be looking at in this IAM model. So let's look at authentication. So authentication design. So authentication can cost a lot of money, depending on how complex, how you want to implement it. You must make sure that your authentication system have some confidentiality, integrity, and availability. The CIA, the tried model, at times you say the DAD, disclosure, You don't want disclosure, right? And you want to make sure that you have credentials very secure. Here in integrity, you want to make sure people cannot change, people cannot pilfer, people cannot adapt, people cannot alter data, right? In availability, you're trying to say that things should be readily possible for people that needs to have access to stuff. So that we don't have unnecessary delay, support issues. It's like if I want to print, can I print? Is that thing available to me? In the first place, for confidentiality, you want to say that people should not access that particular room. You cannot enter into that room, right? Until you are maybe staff. Once I get into the room, I've been granted access. The question is, in integrity, you are saying that can people change things? Can people alter things within that room? That's integrity. For availability, you're now saying that, okay, the thing that I should have access to, is it available to me? For a file on your system, if you want to give an example, you could say it for confidentiality, we're saying that, can I see the file, the content of the file? So you can implement a password system so that I can't see the content in that file. It might be just a Microsoft Word document. You can password it and say, okay, this is the file, but you cannot open it, it's passworded. That's confidentiality. For integrity, you can say, okay, yes, you can, by my access control list, you can see the data. But integrity was saying that you cannot edit the content, you cannot bypass, you cannot change, you cannot alter that content. Then for availability, we're talking about the data being readily available. So for authentication, at times we're looking at something you know. So there are several levels of authentication. So the very, very simplistic one is something you know. So something you know is something like a password, or it can be a PIN. Like, look at this screenshot we have there. You can just enter your password, or it's a PIN, and you have access to the computer. Now, there's some concepts that you need to understand when we look at IAM, identity and access management. Is I want to look at length. What's the length of the password? It should be long enough, it should be complex enough. People should change password from time to time, right? There should be a policy on reuse. That's one of the very important concept in cybersecurity, is the company having a very robust information security policy, because it's going to address most of these things. Then the NIST guidance is very key. That's the National Institute of Standards and Technology. It's an agency in the US, I think part of their commerce industry, that helps to aid innovation and provide guidelines for a lot of stuff in tech. Now, they have robust and enterprise level documentation and guidelines and standards. And I think it's something you want to look up. You could just Google NIST password guide. So because if you're creating your information security policy, you can draw your standard from NIST. Of course, hints like people not using clear words, people not using dictionary words, names. People should not just use numbers like 1, 2, 3, 4. All of those guidelines are important concepts in password. Then we have password managers. So you need to have clarity, and you need to be very careful when it comes to password managers. You have some as votes, you have some in your browsers. Most of the times you are told, do you want to remember your password? And if you do that, what's going to happen is that the browser can store the password for you. But there's a downside to that. So you want to make sure that when you're using third-party plugins or cloud applications or browser managers, you want to make sure that it's very safe and secure. Then, of course, side password generation. At times, to implement a secured system, some systems, we suggest passwords to you. They can tell you to generate a password. Let's say you're creating an account, you put in your name, your bio data, your address, you put in your username, you put in your password. At times, by the side, you can see it, you could see generate password. So the generate password is going to make sure that it conforms to these guidelines and these standards. So that's one way you could have very secured password. Then let's look at multi-factor authentication. So in multi-factor authentication, we're trying to say that we don't want to just authenticate with one factor. We don't want to just give people access with something they know, right? We want to go a step further by saying, don't just give us a password. Can we use also something you have? Now, you see the point here, it's not something you know and something else you know. Not like putting your password, putting your username, putting your password, and putting your date of birth. No. Because those are things you know. We're talking about something you have. So it can be a token, it can be a pin sent to another device, it can be something else, right? So that it's two, it is multi, it's more than one. So once the authentication is not just password, it's more than one means, you call it multi-factor authentication. So you also have something you are, so it can be something you own, then it can be something you do, or something you add, like a fingerprint. So we say enter your username, enter your password, then put your fingerprint, right? Or enter your username and put your facials, right? Or we can say enter your username, enter your password, but we must validate. We must be sure that you are within the office premises. So the system checks the IP. So the IP of the server of the office is bound, or there's a bind between the IP address of the server in the office to that system. So if you're not within the office premises, you cannot access that system. So that's IP network or IP location. So that's a very good way to do authentication. Now, this costs a lot of money. Just like I was explaining to an agency of government in my country some time ago, we were looking at different authentication means. So we said, if I build a system and I just want to have username and password, it costs maybe just the basic amount to develop such application or software. If I now say, okay, I want to send SMS, OTP to the emails, so that means you're doing another authentication. So once you put in your username and password, it takes you to the next screen and asks you for a PIN, or asks you for an OTP, or asks you to enter a token. If it's an OTP, if it's going to be via SMS, it then means that we will need to, if it's an SMS, that we will need an SMS gateway or a bulk SMS gateway. Then we need to pay fees for each GSM number. Then depending on the currency, it can be in cents, it can be in shillings, it can be in Naira. You're going to be paying an amount for each authentication you send, no matter how low. Volume, if you look at 1 million users, that's going to be cost. If you're going to use email, of course, you will need an Exchange server, you will need an email server, or you can use Amazon's simple email services. Once you start doing a lot of volume, that's going to now cost you money. If you now say, okay, I don't want to use SMS, I don't want to use email, I want to use something like a hardware token, it then means to grant people access to that particular system, like most banks, you will need to provide hardware token. So that comes at the cost. I need an authentication server for that. Then aside the cost, the users will have to pay. But you need to set up the infrastructure for that, for users to have such token. So security comes at a cost. If it's going to be maybe geolocation, like that. So each of them, depending on the level of security that you're going to have, it's going to cost you money. So there's need to be a balance between some kind of balance. Just a second. So there needs to be some kind of balance between security. So if this is security, if this is GUI usability, and if this is functionality, right? So this is security. So I have my board here. So you want to make sure that it's a little bit balanced. If you move it towards up here, you have a very secure system, but it might become very unusable for your users, and you might lose out on some kind of functionality. So you want to see how to balance between security, usability and user friendliness of your systems you're creating, and of course, the functionality and the features of that particular software or app. Okay, let's look at biometrics, biometric authentication. So we have this in most phones, but we want to avoid type 1 and type 2 error, false rejection rates for your exams. The throughput costs, inaccessibility, where, for instance, the finger, something is affected, or there's injury, or maybe there's darkness, and we cannot do good facial recognition and all of that. So, but phones and systems, biometric systems have grown over the years. It's not like before. Most of these things are now top notch, and even in the dark, they can pick up your face. I remember just 2 weeks ago, my wife happened to have facial recognition, just like most phones. And I was trying to do something and see if it can recognize my face. Not like we have some kind of resemblance, but you see that these systems have grown to do very, very nice work in terms of authentication. They also have hard authentication tokens. So that's where you have the different types of token generation types. So you have the PKI, the OTP, the FIDO, the U2F. Then you can use smart cards, or you can use one-time passwords, or you can use security keys. So these are means you can provide a system of authentication for users. You also have soft tokens. This is also very common if you don't want to go the hard way, because this comes at a very great cost. You need to get an identity management system. You need to have a company that's going to provide the cards for you, both the swipe cards and the hardware. You need to have a server for that. You need to train employees. You need to build a module for that and integrate it to your systems. So this comes at a very great cost. This is much more cheaper and much more affordable because this is just a software. So you have different authentication systems available. Google have their own authentication system, and most companies have different authentication systems. So if you enter your username and password before you can enter in, you go generate the token and the OTP and you enter it. Or you could do, like I said, you could transmit a code through an outbound channel. It can be SMS, it can be email. And at times, in the earlier years, in trying to implement authentication, people did, or most companies did phone call. But with time, phone call became very expensive because you need a call server. Then it will just pick out a code from the database and call. A voice machine will just call at the number for you, enter in. So most systems used to have this, but it's going down little by little. So we have more of push notification, SMS, email, and different authentication apps. Okay, so passwordless authentication. So this is very common. I think there's a system I set up sometime last 2 weeks. You just put in your username. Sorry, yes, you put in your username, but you don't put in a password. But you put in you don't put a password, you put in like a PIN, or you put in like a number or a combination of character that's going to be sent to an email. So no longer passwords. So this is also a means for authentication. Some of the things we've considered here is authentication design, password concepts, then biometric authentication, hardware tokens, soft authentication, then of course, passwordless authentication. For the lab, we're going to be looking at managing password security. So this is more of threat management. If you want to manage your threats, you can look at maybe having a very good password policy, implementing training, and seeing how to look at your digital assets, look at your risks, your likelihood of occurrence of any attack, then looking at budgets and planning what best method of authentication that you will need to protect your assets. Let's look at asset management. So if we have an asset, if we have files, we have documents, we have whatever that we have data, we have intellectual property, and we want to manage them. Now, there are different ways, there are different controls that we can have. So you might not see this in real life, but these are concepts that are very critical in you trying to plan your own system. Now, access control models determine how users are going to receive permission rights. You could use the CRUD as a very good instance. So I think I might need to start using a board, maybe from subsequent maybe playlist I'm going to be creating, so that I can use a board and do some explainer. So if you're watching up to this point and you have questions, you could ask in the comment section. If you like what you're hearing, or if you like the playlist, you can also let me know from the comment section. Don't forget to like, don't forget to also subscribe and share to those getting security or trying to prepare for the S+ exams. Okay, so we talk about CRUD. So CRUD is create, read, update, delete. So you're asking yourself, what can a user do? Can a user create a file? Can a user create an asset or an object? Can a user read, that is view? Can a user update? Can a user delete? So this is very crucial because that will help you plan what a user can do and the kind of permissions the user have on your system. So we have the first one, which is DAC, discretionary. So this is based on the user. The owner of that particular document can say, okay, I want to give access to so-so person, I want to give access to so-so person. For Mac, you have labels and clearance. So the system is going to restrict access. Then for role-based, so role-based, it can be, let's say we have a role. The role is maybe at times when we say role, we mean functional, for functional kind of systems and functional enterprises, where you have things like, let's say, graphics designer, you have web developer, you have quality assurance team, you have C-level executive. These are different roles, right? So what happens is that you now create different permissions for different types of roles, and you can now, what's it called? Give people permissions based on their roles. Then, of course, for security groups, here you create groups, and you assign user accounts to the groups, and the users inherit the permission on that particular group. So you have an explainer here, that an image, like say these guys are the read group, they can read. So anybody that's in this group, that's put on this group, can actually read. But if you're in this group, you can read and you can write. So so you're put into the group that you are, that the kind of permission that you want to be gotten. Then, of course, attributes. So attributes is a combination of subject and object attributes plus any context-sensitive or system-wide attributes. So you can say for this particular file, we want people to be able to edit, people to be able to do this, people to be able to do this. So this is merely for planning. So in a real situation, you're going to look at what best work for you and see how to combine the different access control list systems for your enterprise. But for your exam, you want to be able to differentiate between non-discretionary methods like the rules, the mandatory access control, role-based access control, and attribute-based access control. And of course, for conditional, which is going to be a continual kind of authentication, or where it's at the user level, where you have permission based on the user account control, or you're going to be having sudos, or you're going to be having permissions based on the user level. Okay, this is a Windows system, and you see this kind of thing in action. If you right-click any folder on your Windows system and you go to properties, you go to permission, you see this kind of interface where you see the different types of permissions being granted and who have that kind of permission, right? So one thing you need to understand for your exams and in security in general is that you should always employ the principle of least privilege. Least privilege means that we want to offer permissions permissions to only what is necessary, to only what is important for that person. For a company, you're going to have people that just come into the firm, maybe consultants, maybe interns, maybe entry-level analysts, maybe full-time role, managers, then executives. So these are different levels. For each level of person that's going to interact with your objects and your data, you want to just provide them only what they need sufficient. So if somebody should just only see a file or see a data or see a particular type of data, that should be only what the person should see. The person shouldn't have privilege going beyond that, maybe to try to change. Or somebody that just comes to a company, maybe as a starter or on probation, there's a kind of things the person shouldn't do on your data set, on your objects, or on your enterprise, or on your platforms. So you should just provide only what the person needs. It's a very important concept, and you're going to see this in your exam. So you also have insufficient permissions. So you should make sure that people get the permission that they need to do what they need to do. If not, you start having backlogs, you start having bureaucracies. Authorization creep. So you don't want people to do things far more than what they're authorized to do. Then you want to be auditing from time to time to make sure that people stay, like we say, stay in their lane. Okay, now user account provisioning, like I said earlier on. So you want to proof identity, you want to issue credentials, you want to allocate assets, you want to allocate files, allocate platforms. Then very important is policy awareness and security education. So you don't have security if you don't have policy awareness. Then you must assign permission. Then once you do all of these things, so here is you trying to prove the identity. Then you want to grant username and password and all of those to the persons. Then once you give that, you want to now say, okay, you can see this, you can see this, you can see that. Then you want to educate people. Here, you want to now assign permissions. Then for the provisioning, you want to say, people shouldn't have, like I used to say when I was in the bank, it's when you leave, when you find out that you cannot have access to some kind of assets within the enterprise, you start thinking that, okay, maybe I'm under probation or I'm about to get a sack. So it's a standard practice to deprovision people, remove and disable permission assignments once people are done with some certain kind of tasks, or when you are exploring job rotation. So job rotation is where you work in this department. Of course, you're going to have some certain level of permission. Then after 1 or 2 weeks, you work in social department. Somebody shouldn't carry along all of his permission as it goes through, right? So you always make sure that you want to deprovision, either a consultant, employee, contractor, trying to leave the company or change his role from one department, because in this department there's some certain kind of things you can do. In this other department, there's some certain kind of things you can do. So you don't want a situation whereby the guy is carrying his permission from let's say a developer to a manager to a marketing staff to an onboarding specialist. If he takes all of those permission across the board, then he's going to have like a super provisioning. So it's a very important concept in security. Then some of the things that you might be provisioning, it's your account, that's your credentials, and the different attributes, the different kind of things the person can do. And at times you might need to do some settings for the individual, depending on the kind of asset you're trying to grant access to. Then we also have access policies. So this comes under information security policy. So every company should have a very detailed information security policy, and an access policy should be part of that information security policies. Just like you should have a website policy, you should have a network policy, you should have a password policy. All of these policies should be under your information security policy. Now, account restrictions. So you could have account restriction is a way to manage to do IAM, to do identity and access management, is to say, okay, we will grant you access based on network, based on geolocation, based on the time of the day. In some systems, you can say, okay, you can only have access within work hours, right? You could provision that with some software, with some hardware. You could say, okay, you can only have access to this system within so time. On some systems, even at off-peak period, if you're accessing the systems maybe at midnight or wee hours, depending on the geography, those times are considered risky times of login. You might be bounced and you might not have access to the next 24 hours. That's what you consider as account restriction. Or you could just do a temporary permission where you say, okay, you only have access for like 1 hour or have access for like 2 hours. Okay, privilege access management. Policies, procedures, I've been talking about this all the while. Technical controls is going to help you prevent abuse of privileged account. So you want to have policies. Policies are so crucial. If you have good policies, it's going to prevent a lot of things. And you could learn from the NIST guideline to prepare a good policy for the enterprise. So the steps in trying to prepare a security policy for your enterprise is first doing an audit. When you do an audit, the next thing you learn from standard guidelines. After you've learned from standard guidelines, that like the NIST framework, you now consult with C-level executives, legal team, managers within the enterprise. The audit is going to help you understand what digital assets you want to protect. So you cannot be doing a policy when the company doesn't run a very robust network, or a network to a particular kind of level. So an audit gives you a full understanding of what is within the enterprise and what kind of assets they have. And also the risks involved, the impact if you have an attack. So that's what an audit does for you. Then when you learn from standard guidelines, you understand what should be and what shouldn't be. That's where the NIST framework and the NIST standard comes from. Then the next thing you want to do is to contact and to look at C-level executives, your managers, the legal team within the enterprise. Because if you have a policy that cannot bite, can just back, then you don't have a policy, because people are going to abuse it. So the policy is going to have procedures, how things should be done, should have the controls, should have the guidelines and all of that. Then another thing you want to do is to make sure that you train. So there's need for security awareness of the policy that you've done. Before you even train, you should submit and it should be reviewed, right? Then you have training, then you have a timeline for review of the document, maybe every 3 months, every 5 months, every 6 months. So this is like the step-by-step process of you preparing an information security policy or a procedure or a set of playbooks or technical controls. So to review, we looked at different types of controls. We also looked at account restrictions. We looked at also privileged access management. So we could use a Linux system to understand how to do permissions in the lab sessions for the students on the internship or the students in the study group. If you have a server, you could do different permissions, or even on Windows, you could right-click and see the different permissions that a folder can have. Or you could take off a hard disk from another system and put into your system, like a slave. They are an external disk. And you can see that there are some files you'll not be able to access because the files on that other drive, you are not the creator. So you might need to change permissions within the folder of the system to be able to have access to the system. Okay, so let's look at 4C, which is identity management. So here we'll look at local network and remote authentication. Okay, so let's look at password versus password hashes. Now, so a hash is a function that's going to make sure that it's added to the password before it's encrypted, before it's stored. So this is going to help security. So instead of just keeping password in their plain format, we can hash them. We could kind of encrypt them. Then you should be conversant, for example, that Windows have different types of authentication systems. So you have the local signing, which is the old regular signing that has already been there. Then you have the network signing, which is Kerberos and NTLM. And also we have remote signing. Then for Linux, that's two options, the PAMS and the etc password system. So for exam, understand these differences as you prepare for the certification exams. Okay, so directory services. So directories are a better way for you to do management of your objects, of your users, or your subjects, of your users, of your computers. So you could use security groups, roles, and services. So you also have an access control list. So you have some kind of authorizations to authorize people, and of all of these guys based on the access you want to grant them. I talked about CRUD earlier on, so you can review that. Then you have different standards like the X500 and Lightweight Directory Access Protocol, that's the LDAP. So you have either a distinguished name or an attribute value pair. So something of this nature, right? So you can say this is for widget web, this is for marketing, this is for widget, this is for UK, this is for widget. So all of this is going to help us provide authorization to subjects trying to have access to objects, right? That's people or items or services that are trying to have access to data. For single sign-on authentication, so if it's Kerberos, understand that there's always a client, there's an application server, and there's a distribution service. Then you also have a ticketing system, you have a ticket granting service. So this is like an illustration of how it happens. You have the request, it goes to the authentication service, it comes back, grants this, and by the side you have an application server that it communicates with. So that's the way single sign-on works. I think I've already explained the difference between single sign-on and federated system. So for federated system, you have different, you trying to have access to different systems compared to a single sign-on when you're trying to have access to different systems within one enterprise, right? The advantage of federated systems is interoperability, right? So there's a shared framework and protocol. So you can use your Gmail, for instance, and access maybe what's it called? YouTube, Gmail, Cisco platform, CompTIA platform. So that's a federation system. Networks under separate administrative control share user identities, right? So one of the ways this can be possible is using the security assertion markup language. So here, this is an open standard. What it does is that we want to be sure that you are who you say you are. So the federated identity uses kind of system, and it comes in very clear XML format. And the communication protocols are HTTPS and also SOAP, Simple Object Access Protocol. So we're trying to say that if we want to do federation identities, or if we want to have federated systems where user identities, one user identity can be able to access different systems, then we can use SOAP through SAML to be able to implement that. Programmers will understand this better, and that's why we normally say as you move on to security, depending on what role you want to play, whether you want to do web security or whether you want to do network security, cloud security, you should be conversant with the intermediate level skill set hands-on for the particular area you want to go into. So if you have questions with respect to which area you should go into, depending on your competence, you could use this comment section and I'm going to do a reply. They will also have open authorization. Here we look at REST. REST is a representative state transfer. So it's a way we can actually CRUD into systems without having access to that system. So this is a framework for implementation, not a protocol. So you have REST systems in payment systems, in user systems. Take, for instance, I'm doing a software and I want to use Google services, let's say Google Drive, and I want my users to be able to have storage systems. If I pay for, let's say, 100 terabytes on Google, I can implement a system on my website using the Google API so that my users can have and pay for the Drive system. So that's where REST comes in. You also have OAuth. So this is designed to communicate authorization rather than explicitly authenticate the subjects. So who have authorization for what? So you also have different flow types for servers to server or mobile app to server. So this is very common for developers, JWT, and of course, JSON. So it can come in web tokens or it could come in JSON formats. The data is being read to be able to see, okay, who have access to this. And once that is authorized, then you could have access to the particular asset. If you have questions with respect to this, you could always ask in the comment section. Okay, so we've looked at different identity management system. We looked at local network and remote authentication, where we looked at different authentication systems for Windows, for Linux. I looked at directory system, single sign-on, federation system, and I differentiated between single sign-on and federation system. Then we looked at SAML and open authorization. Okay, thank you very much for getting through up to this stage. I'm going to see you in the next series, in series 5.